close your eyes for a moment and let your mind travel through space. There's no rush. Take a deep breath and imagine yourself floating gently away from Earth, passing through the orbit of Mars, traversing the asteroid belt like shooting stars frozen in time. Continue your journey until you find the sixth planet from the Sun, a celestial jewel that shines with unique splendor in the void of the cosmos. You have arrived at Saturn. Saturn is unlike anything we know here on Earth. It's not a world of rock and earth like ours. It's a gas giant, an immense sphere composed mainly of hydrogen and helium, the simplest and oldest elements in the universe. Imagine an entire planet made of the same gases that fill a party balloon, but on such a monumentally large scale that it defies our comprehension. There are no beaches, no mountains, no ground to land on. Just layers upon layers of turbulent atmosphere, descending ever deeper into a mystery we still don't fully understand. But what makes Saturn truly unforgettable? What transforms it into the most photographed and admired planet in our solar system are its rings. No other planet possesses rings so extensive, so bright, so absolutely magnificent. They encircle the planet like a divine halo, a cosmic crown that seems to have been designed by a celestial artist. When you look at Saturn through a telescope for the first time, it's impossible not to feel a wave of awe. It's too beautiful to seem real. These rings are made of billions of fragments of ice, dust, and tiny pieces of rock, each orbiting the planet at its own pace, in its own silent dance. Some fragments are as minuscule as grains of sand. Others are as enormous as mountains. Together, they reflect the light of the distant sun and transform Saturn into a bright lantern in the night sky. The first person to point a telescope at Saturn and actually see it was Galileo Galilei in 1610. Imagine his surprise. At that time, telescopes were primitive, with blurry lenses and limited magnification. When Galileo looked at Saturn, he saw something strange. The planet wasn't round as he expected. It seemed to have protrusions on both sides, as if it had ears. He couldn't understand what he was seeing. For years, Galileo watched these ears appear and disappear, changing shape, completely confusing him. He never knew in his lifetime that he was seeing Saturn's rings from different angles. It was only decades later that other astronomers acquired better telescopes and finally understood the truth. Saturn was wearing a magnificent crown. Saturn is not alone on its journey around the Sun. It is accompanied by a large family of moons. So far, we have confirmed the existence of at least 146 moons orbiting this gas giant. Each one has its own history, its own personality. But the largest and most fascinating of all is Titan. Titan is so large that it surpasses the planet Mercury in size. It's a moon with a dense atmosphere, clouds, rain, and even oceans. But these aren't oceans of water like ours. They are oceans of liquid methane and ethane, substances that exist only as gases on Earth. On Titan, it's so cold that the methane condenses and flows like rivers, forming lakes and seas under an orange, hazy sky. It's an alien world in the purest sense of the word, a place where chemistry behaves in ways that defy our terrestrial experience. Returning to Saturn itself, there's something almost magical about its density. This giant planet, with a diameter 9 times greater than Earth's, is so light relative to its size that it would float on water. If you could find an ocean large enough to contain it, Saturn would float like a giant cork. It's hard to imagine a planet floating, but that's the strange nature of gas giants. They are immense, yet surprisingly light. Time works in a peculiar way on Saturn. A day there lasts only about 10 hours and 33 minutes. The planet rotates on its axis so quickly that a full day passes before you even have time to watch 2 movies in a row. But a year on Saturn, the time it takes to complete an orbit around the Sun, lasts an impressive 29 Earth years. Imagine celebrating your birthday once every 3 decades. A child born on Saturn would still be a child when their Earth parents were already elderly. Saturn's atmosphere is a place of extremes. Winds with speeds of up to 800 kilometers per hour tear through the clouds, becoming the fastest winds in the entire solar system. These storms make a terrestrial hurricane seem like a gentle breeze. And it's cold. Very cold. The average temperature at the top of the clouds drops to 178 degrees Celsius. It's a cold that would instantly freeze anything we know. There is no ground on Saturn. If you could somehow dive through its atmosphere, you would descend through layer upon layer of increasingly dense and hot gas. The pressure constantly increasing until eventually, deep down, you would find a dense and mysterious core. But there is never a moment when you would land on solid ground. Saturn is a world without a surface, a planet made only of atmosphere to its very core. Saturn's extraordinarily low density, even lower than that of water, is a reminder of just how different worlds can be. We think of planets as solid spheres, but Saturn completely defies that notion. The rings, despite their grandiose appearance, are surprisingly thin. They extend for hundreds of thousands of kilometers in diameter, but are only 10 meters to 1 kilometer thick. It's as if they were a gigantic paper disc floating in space. And there are moments, as seen from Earth, when the rings are perfectly aligned sideways in relation to our perspective. When this happens, they practically disappear from view, as if Saturn had removed its crown for a moment. It's a trick of cosmic geometry that fascinates astronomers and sky observers. Like its neighbor Jupiter, Saturn also harbors a great spot, a massive storm in its northern hemisphere that persists for years. It's a hurricane the size of a smaller planet, swirling tirelessly in the turbulent clouds. And there's something even more mysterious about Saturn. It emits more heat than it receives from the Sun. Somehow, the planet is generating its own thermal energy. This is believed to be due to internal gravitational compression. Helium deep within Saturn is constantly falling towards the core, and this process generates heat. It's as if the planet has a heart that still beats with the heat from its formation billions of years ago. Continue your journey now, delving deeper into the mysteries of Saturn. Breathe slowly and let your mind drift gently around this golden giant, observing details that few stop to contemplate. Saturn's rings, so magnificent when viewed from afar, reveal an impressive complexity when examined closely. They are not a single, uniform structure. In fact, they are classified into 7 major groups, each with its own character and composition. Astronomers have named them with simple letters: A, B, C, D, E, F, and G. Each ring is separated from the others by subtle gaps, like tracks on a cosmic vinyl record. The most impressive of all is Ring B, the widest and brightest, the one that captures the most sunlight and makes Saturn shine like a jewel in the night sky. Where did these rings come from? This question still intrigues scientists. One theory suggests they were formed by the destruction of an ancient moon. Perhaps billions of years ago, a moon of Saturn came too close to the planet and was torn apart by gravitational tidal forces. Its fragments would have scattered in orbit, gradually forming the rings we see today. Another possibility is even older. The rings may be primordial remnants from the formation of the solar system itself, material that never managed to coalesce to form a moon, remaining in orbit for more than 4 billion years. They are frozen memories of the birth of the planets. Our understanding of Saturn was completely transformed by a spacecraft called Cassini. For 13 years, this probe traveled around Saturn, studying every detail, diving between the rings, approaching the moons, collecting data that took decades of planning and construction to obtain. Cassini revolutionized everything we knew about this distant world. It was as if we had finally put on glasses after years of seeing only blurry shapes. Each image sent back revealed new wonders. One of the most extraordinary discoveries was Saturn's hexagon. At the planet's north pole, there is a perfectly hexagonal cloud formation. It's not a circle, it's not an irregular patch. It's a geometric hexagon with 6 almost perfectly straight sides. This structure is 30,000 kilometers wide. To put that into perspective, you could fit 4 Earth-sized planets inside this hexagon and still have room to spare. It's a storm that has maintained its geometric shape for decades, possibly centuries, challenging our understanding of how atmospheric patterns behave. It's as if nature had drawn a perfect figure in the clouds, using only wind and pressure. At Saturn's poles, auroras dance across the sky. Just as on Earth, where the solar wind interacts with our magnetic field, creating the aurora borealis, Saturn also possesses this spectacle of lights. Curtains of colored radiation shimmer over the poles, invisible to the human eye in visible light, but brilliant at other frequencies. They are luminous ghosts dancing in the void. Saturn's characteristic coloration, that yellowish golden hue that makes it so distinctive, comes from chemical compounds floating in its atmosphere, especially ammonia. These substances absorb and reflect light in specific ways, painting the planet with warm tones reminiscent of honey or old gold. Saturn's winds are monumentally fast. In the equatorial region, they blow faster than all of Earth's winds combined. These atmospheric currents circle the planet at speeds that would make any terrestrial hurricane seem like a gentle breeze. And all of this happens in absolute silence, because in the vacuum of space, there is no air to carry the sound of these colossal storms. Let's return now to Saturn's moons, because they are worlds unto themselves. Titan, the largest of them, has an atmosphere denser than Earth's own. While our atmosphere is primarily nitrogen and oxygen, Titan's is dominated by nitrogen and methane. And this methane behaves on Titan in the same way that water behaves here. There are methane rains falling from orange clouds. These rains form rivers that meander across the icy surface, emptying into lakes and seas of liquid hydrocarbons. Imagine being on the shore of a lake on Titan, looking at a hazy horizon, feeling a methane rain touch your spacesuit, seeing waves of ethane gently breaking on the shore. It's an alien hydrological cycle, familiar and strange at the same time. But Titan isn't the only fascinating moon. There's Enceladus, a small icy moon that hides an impressive secret. At its south pole, enormous geysers spew salty water directly into space. These plumes of ice and vapor rise hundreds of kilometers above the surface before falling back down or escaping into space. Cassini flew through these plumes and detected not only water, but also complex organic compounds and salts. This means that beneath Enceladus' icy crust, there is a global ocean of liquid, salty water, heated by gravitational tidal forces. And where there is liquid water, energy, and chemical compounds, there may be life. Enceladus has become one of the most promising places in the solar system to search for microscopic life beyond Earth. Something may be swimming in that dark, warm ocean, never having seen the stars. Another small moon has caught attention for its peculiar appearance. Mimas has a gigantic crater on its surface that makes it look strikingly like the Death Star from Star Wars. It's a fun cosmic coincidence that a real moon looks so much like a fictional space station from a movie. The crater was likely caused by a massive impact long ago, nearly destroying Mimas completely. Titan is so large that it is second in size only to Ganymede, Jupiter's largest moon. It is the second largest moon in the entire solar system, a world worthy of being called a planet if it were orbiting the Sun directly instead of orbiting Saturn. Interestingly, if you could somehow stand on the top layer of Saturn's clouds, the gravity you would feel would be almost the same as on Earth. About 1.07 g, only slightly greater. Your body wouldn't notice much difference. Sure, you'd be standing on turbulent clouds on a planet without a ground, but at least you wouldn't be crushed or floating uncontrollably. Saturn's visible surface, its cloud layers, shows bands and patterns similar to those of Jupiter, but they are much less distinct. Saturn has a smoother, more homogeneous appearance, as if covered by a golden haze that softens all the details. It is a more visually understated planet than its more dramatic neighbor. Saturn is surrounded by a gigantic magnetosphere, a magnetic field that extends up to 1 million kilometers into space. It is an invisible shield that protects the planet and its moons from intense solar radiation, creating a magnetic bubble where the entire Saturnian family exists safely. Imagine this complex and beautiful system. A rapidly spinning golden planet, surrounded by shimmering ice rings, accompanied by dozens of moons, some with hidden oceans, others with dense atmospheres, one with methane lakes, another spewing geysers into space. And above the North Pole, a perfect hexagon of storm, defying everything we thought we knew about how planets behave. Dive deeper now into the secrets of Saturn. Let your mind explore unseen layers, colossal magnetic forces, and icy worlds that defy everything we imagine about how nature works. Saturn's magnetosphere is not merely a passive shield. It actively captures charged particles from the solar wind, trapping them in radiation belts similar to those around Jupiter. These particles remain trapped, circling the planet indefinitely, creating invisible zones of intense energy that would be lethal to any unprotected visitor. It's as if Saturn were wearing invisible armor, layers upon layers of magnetic fields protecting its system of moons from the violence of space. The rings shine with an almost hypnotic intensity because they reflect about 80% of the sunlight that hits them. It's an impressive efficiency. Most surfaces in space are dark, absorbing light. But Saturn's rings, composed mainly of pure ice, act like giant mirrors, returning almost all the light they receive to space. That's why they appear so luminous, so almost unreal when viewed through a telescope. Saturn's atmosphere is organized into distinct layers, Near the top, we find molecular hydrogen and helium floating freely. Further down, clouds of ammonia appear, giving the planet its characteristic color. Each layer has its own temperature, pressure, and chemical composition. It's a layered structure like an atmospheric cake, each band with its own unique properties. The deeper you descend into Saturn, the more extreme the conditions become. The pressure increases exponentially until it reaches such absurdly high levels that even gaseous hydrogen transforms into metallic hydrogen. Yes, a gas can become a metal under sufficient pressure. In this state, hydrogen behaves like a conductive liquid, similar to mercury, flowing and generating magnetic fields. It's hard to imagine, but at the heart of Saturn, there is an ocean of metallic hydrogen, something that cannot exist naturally anywhere on Earth. Saturn's incredibly rapid rotation has visible physical consequences. The planet spins so fast on its axis that centrifugal force pushes its equator outward, causing it to bulge in that region. The poles, in turn, become flattened. The result is that Saturn's diameter at the equator is about 10% larger than its diameter from pole to pole. If you could measure it, you would find that Saturn is not a perfect sphere, but rather a flattened spheroid, a ball slightly squeezed at the sides. Storms on Saturn are long-lasting phenomena. While on Earth a hurricane lasts days or weeks, Saturnian storms can persist for months or even years. In 2011, the planet experienced a superstorm so massive that it literally circled the equator. It was a band of turbulence that encircled the entire planet, a temporary scar of violent clouds that astronomers were able to track for months. Imagine a storm so large that it has no beginning or end, just a continuous loop of atmospheric fury. Between the rings, there are fascinating gaps called divisions. The most famous and largest of these is the Cassini division, named after the astronomer who discovered it centuries ago. This gap is about 4,800 kilometers wide. To put that into perspective, it's larger than the distance between São Paulo and Manaus. It's a void in the middle of the rings, an empty cosmic highway kept clear by the gravitational influence of some of Saturn's moons. Particles simply avoid this region, leaving a dark space amidst the brightness. The rings are not eternal. Scientists have discovered that they are slowly disappearing. Ice particles are constantly falling towards the planet, pulled by gravity, vaporizing in the upper atmosphere. If this process continues at the current rate, the rings could disappear completely in about 100 million years. It's a reminder that even the most majestic structures in the universe are temporary. Saturn will one day be just another gas giant without its characteristic corona. Saturn's moons continue to surprise us. Iapetus is particularly strange, with one bright side and another extremely dark side, as if someone had painted half of it black. No one knows for sure why this happens, but it's probably the result of dark material accumulating on one hemisphere over millions of years. Another moon, Hyperion, has a completely irregular shape, resembling a giant sponge or a cosmic potato covered in deep craters. It doesn't have enough gravity to mold itself into a sphere, so it maintains this chaotic and fascinating appearance. The very particles that make up the rings are in constant, rapid motion. They orbit Saturn at over 70,000 kilometers per hour, each fragment on its own trajectory, occasionally colliding, breaking apart, and regrouping. The rings are a frenetic ballet of billions of objects, from tiny grains of dust to icy blocks the size of a house, all dancing in perfect formation. Deep inside Saturn, it is believed that there is a dense, hot, rocky core surrounded by successive layers of liquid and metallic hydrogen. It is a layered structure that makes Saturn function like a giant cosmic onion. Each layer has different properties, different temperatures, and different states of matter. The seasons on Saturn last an eternity in human terms. Due to its long orbit around the Sun, each season lasts for more than 7 Earth years. The Saturnian summer lasts 7 years. Winter, another 7 years. Imagine living through 7 years of continuous winter, followed by 7 years of summer. Of course, since Saturn has no solid surface and is so far from the Sun, these seasons are more subtle than ours, manifesting mainly in atmospheric changes and the angle at which sunlight hits the rings. Returning to Titan, this extraordinary moon possesses gigantic dunes on its surface. But these dunes are not made of rocky sand like those of the Sahara. They are composed of hydrocarbons, dark grains of organic material that have been blown by methane winds over eons. Imagine deserts of black, oily sand under an orange sky, sculpted by winds carrying chemical compounds instead of water. Enceladus, small and icy, reflects almost all the light it receives from the distant sun, making it one of the brightest objects in the entire solar system. Its pure ice surface acts like a perfect mirror, returning light with impressive efficiency. And it was on this bright moon that the Cassini probe made one of the most exciting discoveries of the modern space age. By flying through the jets of vapor that Enceladus expels into space, the probe detected complex organic molecules. Not just water and salts, but chemical compounds that on Earth are associated with life. It's impossible not to wonder. Is there something alive swimming in that ocean hidden beneath the ice? Breathe slowly and allow your awareness to float through the layers of knowledge that humanity has accumulated about this distant and fascinating world. Saturn's extraordinarily low density tells us a fundamental story about its nature. This immense planet, with a diameter almost 10 times greater than Earth's, is composed almost entirely of gas. There is no solid land waiting for explorers. There are no oceans of water. Only gas upon gas upon gas, compressed by gravity into ever denser layers until the very definition of gas ceases to make sense, and new states of matter emerge. That characteristic golden color of Saturn has an elegant chemical explanation. Crystals of frozen ammonia float in the upper layers of the atmosphere, refracting and reflecting sunlight in specific ways that produce that warm, yellowish hue. It's as if the planet were enveloped in a golden haze, a veil of microscopic crystals that paint it with shades of old honey. Deep within Saturn, the pressure reaches such absurdly intense levels that it compresses elements into exotic states of matter that we have barely begun to study in the laboratory. States that do not exist naturally anywhere on Earth, where physics behaves in counterintuitive and fascinating ways. It's as if the interior of Saturn were a laboratory of extreme physics, conducting experiments that we could never replicate. Saturn's moons do not orbit the planet independently and randomly. Some of them are locked in orbital resonances, gravitationally influencing each other like invisible gears in a cosmic machine. When one moon completes 2 orbits, another completes exactly 3. This type of gravitational synchronicity keeps the system stable over billions of years, each moon pulling and pushing the others in a delicate and precise balance. Enceladus' subsurface ocean is kept warm by a process called tidal heating. Saturn's gravity is not uniform. As Enceladus orbits, it experiences gravitational forces that constantly squeeze and stretch it, as if a giant invisible hand were kneading the moon. This process generates heat through internal friction, enough to maintain a global ocean of liquid water beneath kilometers of ice. It is heat born from pure gravitational force. Titan possesses a remarkable distinction in the solar system. It is the only body, besides Earth itself, that has stable liquids on its surface. Not water, of course, but methane and ethane. These lakes are vast. Some are equivalent in size to Lake Superior in North America. Imagine standing on the shore of one of these lakes, peering through a thick orange mist, watching waves of hydrocarbon gently break against an icy shore. Titan's orange atmosphere owes its color to particles called tholins, complex organic compounds produced when ultraviolet sunlight breaks down methane and nitrogen molecules. These particles accumulate in dense layers, giving Titan's sky that characteristic appearance of a perpetual sunset. It's as if the entire planet is enveloped in a twilight haze. Saturn has been visible to the naked eye from Earth for thousands of years. Ancient civilizations looked to the night sky and saw that yellowish point of light moving slowly among the stars. They didn't know about rings or moons, but they recognized that it was special. In Roman mythology, Saturn was the god of agriculture and time, a deity associated with cycles, harvests, and the inexorable passage of the seasons. It makes sense that a planet that takes 3 decades to orbit the Sun would be named after the god of time. Weather activity on Saturn includes lightning storms far more powerful than anything we experience on Earth. These are not small electrical discharges. They are lightning bolts that can persist for up to 10 hours at a time, illuminating the turbulent clouds with continuous brilliance. Imagine a storm where the lightning simply doesn't stop, where electricity flows constantly through the atmosphere like a river of light. The Cassini probe revealed that Saturn possesses dust belts invisible to the human eye, ghostly structures detected only with sensitive instruments. These are additional, faint, and diffuse rings that encircle the planet in regions where we never imagined anything could exist. Saturn's E-ring is the widest of all, stretching for 1 million kilometers. It's so diffuse and transparent that it would be nearly impossible to see if you were floating in the middle of it. And there's something extraordinary about its origin. Part of the E-ring is constantly fed by jets of vapor from Enceladus. That small, icy moon is literally creating one of Saturn's rings. Every moment, geysers spewing from Enceladus add material to the ring, replenishing it with ice particles that then orbit the planet indefinitely. Another moon, called Rhea, may have an extremely thin oxygen atmosphere surrounding it. Not the kind of atmosphere you could breathe in, but a tenuous layer of oxygen molecules created when solar radiation breaks apart frozen water molecules on the surface. It's an almost imperceptible atmospheric envelope, but its mere existence is fascinating. Titan doesn't just have lakes. It has a complete climate cycle. There are methane rains falling from clouds, rivers snaking across the surface, lakes evaporating and forming new clouds. There are even seasons, periods when different regions experience more or less precipitation. It's an alien climate system, but surprisingly familiar in its basic structure. Saturn's frenetic rotation places it on the edge of stability. If the planet were just a little smaller, while maintaining the same rotation rate, it would have become gravitationally unstable. It's as if Saturn is exactly at the equilibrium point between spinning too fast and collapsing under its own mass versus remaining stable. Any significant variation would have created a very different planet, perhaps even preventing the formation of the rings. Saturn's interior continues to generate heat through a process called Kelvin-Helmholtz contraction. The planet is slowly shrinking under its own gravity, compressing its interior. This compression converts gravitational energy into heat, which then radiates into space. This is why Saturn emits more energy than it receives from the Sun. It is still cooling since its formation, a process that will take billions of years to complete. Saturn's upper clouds can reach impressive heights of 300 kilometers, forming atmospheric towers that rise like gaseous skyscrapers. These gigantic structures are constantly shaped by fast-moving winds, creating patterns that flow and change over days and weeks. Saturn's atmosphere is so incredibly thick that sunlight takes hours to penetrate it completely. Imagine layers upon layers of hydrogen and helium, so dense that even light struggles to pass through them. It's a world shrouded in golden haze. Just as Jupiter has its great red spot, Saturn also harbors permanent storms. At the planet's south pole, there is a gigantic hurricane that never ceases. The eye of this storm can be up to 8,000 kilometers in diameter. You could fit the entire North America inside it. It's a meteorological structure so vast that it defies comprehension. Saturn rotates so rapidly on its axis that scientists have difficulty accurately determining the length of a Saturnian day. The planet has no solid surface to serve as a point of reference, and different atmospheric layers rotate at different speeds. It is a world where even time becomes ambiguous. Interestingly, Saturn's magnetic field is almost perfectly aligned with its axis of rotation, a rare feature among planets. On most worlds, including Earth, there is a significant tilt between the magnetic and geographic poles. Saturn is different, almost as if perfectly symmetrical in its magnetic properties. Among Saturn's moons, Dione may be hiding a secret beneath its icy surface, possibly a subsurface ocean, similar to what we find on Enceladus. The more we explore the Saturnian system, the more we discover that it may harbor multiple hidden water worlds. Some of Saturn's small moons are bizarre in appearance. Pan and Atlas, for example, look like flying saucers, literally. They have accumulated so much material from the rings over millions of years that they have developed prominent equatorial belts, giving them a characteristic UFO shape. Saturn's composition is remarkably simple. Less than 1% of its total mass is made up of elements heavier than hydrogen and helium. It is almost purely made of the lightest elements in the universe, a giant ball of primordial gas. And what a giant it is. You could fit 760 Earths inside Saturn and still have room to spare. It is the second largest planet in the solar system by mass, second only to the colossal Jupiter. Together, these two giants gravitationally dominate the outer solar system. Descending through Saturn's atmospheric layers, the temperature would increase dramatically. Near the core, if there is such a thing as a solid core, temperatures can exceed 11,000 degrees Celsius. It's a gaseous inferno where the pressure is so intense that hydrogen behaves like liquid metal. The color of Saturn's clouds is not static. It changes slowly throughout the planet's seasons, and Saturn's seasons are long, each lasting about 7 Earth years, because the planet takes almost 30 years to complete an orbit around the Sun. If a human were to attempt to land on Saturn, there would be no landing at all. You would sink indefinitely through increasingly dense layers of gas, the pressure continuously building until it crushed any spacecraft or body. There is no solid surface waiting at the end, only increasing pressure until eventually the hydrogen becomes so compressed that it acts like a metallic fluid. Saturn's rings are more than just beautiful. They're a natural laboratory. Studying them helps us understand how young planets form from disks of dust and gas around newborn stars. It's like watching planetary formation in action, frozen in a cosmic moment. Saturn is so far from the Sun that sunlight there is approximately 100 times fainter than on Earth. If you could stand on the surface of one of its moons, the Sun would appear as just a very bright star, not the radiant disk we know. The planet also generates lightning, electrical discharges so powerful that they produce radio waves detectable millions of kilometers away. These are electrical storms on a scale that would make any terrestrial storm seem like child's play. Saturn's beautiful rings may be surprisingly young. Evidence suggests they may have formed only 100 million years ago, recent in cosmic terms. This means that the dinosaurs were already extinct when the rings were born. They may be a temporary phenomenon, destined to disappear in a few million years. Saturn's atmosphere is so deep and gradually becomes denser that there is no clear boundary where it ends and the interior begins. It's a gradual transition from thin gas to dense gas to fluid, without defined boundaries. It's a planet without a surface, a giant without land. In September 2017, after 13 years exploring the Saturnian system, the Cassini probe made its last and most dramatic maneuver. It deliberately plunged into Saturn's atmosphere, sending back precious data until the very last moment before being destroyed by the pressure and heat. It was an epic end to one of the most successful space missions in history. And finally, though invisible to our eyes, Saturn possesses a constant aura of electromagnetic radiation, a unique energy signature in the solar system. It's as if the planet sings a note that only specialized instruments can hear, a cosmic melody that resonates through the vacuum. And now, as you prepare to sleep, know that the Earth continues to revolve beneath you, that Saturn continues to orbit silently in the outer reaches of the solar system, that the universe continues its eternal dance of creation and transformation. You are part of all of this. You are the universe contemplating itself. Sleep well. Dream of distant worlds and the hidden wonders of your own planet. Good night.